Okay, guys, today we're doing something pretty similar with just another little addition, of course. So, number one's pretty easy. I'm going to skip ahead and do number two with us just to get us started today. So, when we're doing these, when I start, I like to look at the roots and see if they are whole numbers. And if I can, I know that I can go quickly to factored form. So, hint, hint, for like number one, that'll give you a pretty good idea how to write it into factored form. So for two, they don't cross real nicely, so that's kind of the one that I wanted to start with. So when they don't start real quick or real nicely, factored form is probably not the first place to go. So that would be going for standard or for vertex. If I was going for standard form, I might look and see that C is 2. I know that, right, because it's the y-intercept. And then I could plug in different points, kind of like we did at the beginning of the year, if you remember one of the first days of school. Or I could go to vertex form, which is going to be a little bit easier. So the vertex of this, right here, and go ahead and label it on your side as well, is -2, -2. Now, when I put that into vertex form, it would be f of x is equal to x plus 2 squared minus 2. Now, the only question is if there is an a value here. So just as a review, and I talked to a couple of you guys about this yesterday, and we're doing a little bit better with it. Remember what happens when a is equal to 1. So if a is equal to 1, parent function is, I'll just write in the number 1, and a, no, 1 is a, so 1 x squared. And just remember that here a is 1, right? So if x is 0, y is 0, because 0 squared times 1 is 0. If x is 1, 1 squared is 1, times our a value of 1 is 1. And if I put in 2, 2 squared is 4, and 4 times 1 is 4. And then 3, 9, and I'm sure that you can pick up on the pattern from there. So we just need to see if that is exactly what's going on here. So I know that this is going over 2, and then here's another spot where it hits the graph nicely. And I know that that is going up 4. So when x is 2, y is 4. And I come over here and I match it up, and now I have proved to myself that a is equal to 1. You don't have to write it in if you don't want to, but we have now solved for vertex form. Okay, now to take it from vertex form to another form, like standard form, for example. So standard form, we have to take our function, and we have to FOIL and combine like terms, and we will end up in standard form. So our standard form equation is f of x is equal to x squared plus 4x plus 2. Okay, so let's take it now into factored form. Okay, oops, I just erased vertex form though. So let me put that back in here. Okay, so for factored form, we would try to go like this and find something that multiplies to 2 and adds to 4. And there are no such whole numbers that do that. So it seems like we're kind of stuck. Just because the factored form isn't whole numbers, that doesn't mean that there isn't a factored form with numbers that are not whole numbers. So this is where we need a little assistance today in what to do. So I want you to pretend for a second that you have a very, very simple quadratic, and you plugged it in to the quadratic formula, and at the end you found out that x was equal to 3 and 9, for example. So I could, just from getting the end of the quadratic formula, I could then write the factored form from this, knowing that those were the answers, right? Okay, so what I'm telling you is that we got to plug this into the quadratic formula and see exactly what the answers are. Or another route, I suppose, would be to solve the vertex form, which I think I may do. Instead, solve the vertex form for x, and that will also get me the answers. Let's do it that way. Okay, you are going to stop there, because what we're starting to see is that this -2 is this, and the square root of 2 is this, and the negative square root of 2 is this. So if we're putting this into factored form, remember what it was like when it was easy answers. Right? Complex answer. Factored form. You can write it under factored form. Okay, I'm going to pause and have you guys talk about it in your groups about why this is, in fact, the answer, and how this is really similar to this. So hopefully that helps you. We now got all three, standard, factor, and vertex. We didn't even know the roots from the beginning, but we do have an idea of them now, and we could calculate them as a decimal if we really wanted to. So